What up, geometry students? We're going to do the Unito test review. If your teacher allows and you're on Digi exam, you can use Desmos to help with your work. It's very valuable to do it. As you can see, for example, simplifying the square root of 32. The square root of 32 is the number 5.656. However, we do not want to leave that as our answer. This decimal, which goes on forever and ever and ever, it doesn't stop at 9. So, as a shout out to mathematicians who did not have calculators, we want to simplify this into the square root of a perfect square times a non-perfect square when possible. We need to remember the perfect squares like 4, 9, 16, 25, 36, etc. You can always just provide these numbers for yourself. And we want to take our number 32 and see what perfect square divides. Now, we want to start with the bigger numbers. If I start with 4, I'm actually not going to be perfectly simplifying. So I realize that 16, which is a perfect square, times 2 is 32. So what I end up doing is writing root 32 as root 16 times root 2. I can see that I get that same number. So again, I'm just rewriting this. I'm not changing it. And the reason why we write root 16 root 2 is because the square root of 16 is 4. So if I write 4 times the square root of 2, I can see I have that number 5.656, which is the simplified version of square root 32. So we get 4 root 2. Okay, and then we just kind of continue that process. We now want to simplify the square root of 60. I'm going to start taking 60 and dividing it by perfect squares. Yeah, 25 doesn't work, 36 doesn't work, 16 doesn't work, 4 works. So root 60 is root 4, root 15. Good. The square root of 4 is 2. 2 root 15 is the simplified version of root 60. Now we're on to 34. Well, 34 does not get divided by 4 evenly, does not get divided by 9, does not get divided by 16, does not get divided by 25, which means we cannot rewrite the square root of 34 as a number times the square root of a different number. The square root of 34 is simply the square root of 34. You might think about doing 2 and 17, but if you think that the square root of 2 is 2, that's wrong. It's not. You can see that if I all of a sudden change this to 2 root 17, I don't have the same number. So root 2 root 17 doesn't help you. So we leave our answer as root 34. Now we have 2 root 49, and we realize that that's just going to be 14. Why? Because the square root of 49 is 7. So we have 2 times 7. 2 times 7 is 14. Now we have 3 times the square root of 8. I'm going to focus on the square root of 8. The square root of 8 is the square root of 4 times the square root of 2. But look at the number change. Why did that change? Because I don't have 3. So I should understand that the 3 is going to stick around. The square root of 4 is going to turn into 2. I have 3 times 2 times the square root of 2, or I have 6 times the square root of 2. Notice how my number is the same. If you are doing this incorrectly, the number that you're having is going to change. So be ready for that. And it's the same thing for 6 square root of 18. I'm going to say 18 is 9 times 2. See how my number is the same? The square root of 9 is 3. 6 times 3 is 18. So 18 square root of 2 is the same as 6 square root of 18. Cool. Now we got some right triangles. Pythagorean theorem is our unifying length equation for triangles. An isosceles right triangle has a hypotenuse length of 10. Well, that means that this side length A or this side length x is the same as this side length x, and we have a squared plus b squared equals c squared. Well, x squared plus x squared is 2x squared. 10 times 10 is 100. Divide by 2, I get x squared equals 50. Square root to find the number that times itself gives us 50. That's the square root of 50. The square root of 50 can be simplified. Square root of 50 is that. This number times itself is 50. Cool. But 50 can be taken and divided by 25, which is a perfect square. So 5 root 2 is our simplified answer. This is the answer. This is the answer. This is unsimplified. This is simplified. Cool. We got an hypotenuse length 10. One of the legs is twice as large as the other. So I have x and 2x. What are the lengths of the legs? So I have a squared plus b squared equals c squared. A squared. B squared is 2x times 2x. 2x times 2x is 4x squared. C squared is 100. 1x squared plus 4x squareds are 5x squareds. Divide by 5, I get x squared equals 20, which means x equals the square root of 20, which is the square root of 4 times the square root of 5, which is 2 times the square root of 5. Root 20 is an answer. That is the length of one of the legs, which means 2 root 20 is the length of the other leg. However, I want the simplified version 2 root 5, which then doubled would be 4 root 5. This is 2 root 5 doubled. This is 4 root 5. An isosceles right triangle has two sides of length 4. Okay, well, if it's two sides of 4, those are going to be the two legs because the hypotenuse is always the longer side. A squared plus b squared equals c squared. 32 equals c squared. Didn't we take 32 earlier and say it's 16 times 2? Didn't we simplify the square root of 32 earlier? Yeah, we did, right here. So we need to just understand that c is root 32, which is root 16 root 2, which is 4 root 2. Cool. These are some extra Pythagorean theorem questions. It's just a little bit more involved. You might not have seen these in your homework, but they're totally doable. We can see we want to find x, but to find x, we need to find this length. To find this length, we need to use the Pythagorean theorem in this triangle, where we have an a squared plus a 4 squared equals a 5 squared, which will give us x squared equals 9 after subtracting, which gives us x equals 3 after square rooting. The square root of 9 is 3. I should probably include that. So if x squared equals 9, x equals the square root of 9. The square root of 9 is just 3. Great. Now I'll use the Pythagorean theorem in the second triangle, where I have a 3 squared, which is 9, plus a 6 squared, which is 36, equals my c squared, or my x squared. 36 plus 9 is 45. We can do a little bit of work here. We want to square root that. So the square root of 45, we can take 45 and start dividing it by numbers. 9 works. 9 times 5. So the square root of 9 times the square root of 5 is 3 square root 5, which is the simplified version of the square root of 45. So you should put that x equals the square root of 45. But then you should simplify that so that we get the simplified version. All right, kind of same thing here. I need to find this missing length here. I probably shouldn't have put x. I probably should have put like a. So we want to find a in the triangle with the 10 and the 9, and then after finding a, we want to find x. we notice that 10 is the hypotenuse, so a is a leg, so it'll be a squared plus 9 squared equals 10 squared. 100 minus 81 is 19. Cool. So a squared equals 19, which means a is root 19. Now, what's interesting about that is like, yes, a is root 19, but in our second triangle with the 5 and the root 19, we know that we need to use a squared plus b squared equals c squared. Well, I already know what root 19 squared is. A squared is 19. So we could just leave it like that. And we want to find the hypotenuse x squared. So 25 plus 19 is 44. 44 is x squared, which means x is the square root of 44. The square root of 44 is the 6.633 number, but we want to simplify that. Shout out old school mathematicians. Divide 44 by 4, and we get 4 times 11. So I get 2 times the square root of 11 is the simplified root 44. All right, let's find some lengths. Remember, with lengths, every time we have a line segment in the coordinate plane, we have an x distance and a y distance. We love to put our points on top of each other so we can see an x change and a y change. From 0 to 3 is plus 3. From 0 to 2 is plus 2. And all of a sudden we see this right triangle. We have an a squared plus a b squared equals this diagonal length squared. C squared equals 13, which means c equals root 13. So from 0, 0 to 3, 2, which is the length of AB, we have root 13. Let's go from C to B. So let's go from 0, 4 to 3, 2. I can see my x change is plus 3. I can see my y change is minus 2. A squared plus b squared equals c squared. We have c squared equals 13 again, so c is also root 13. So CB is root 13. So it looks like we're creating this right triangle. BC is root 13. And from 0, 0 to 0, 4, that's an easy one. We go straight up. 4, we don't need the Pythagorean theorem. We just get that. All right, cool. So we get this right. Looks like this right triangle. But we can kind of see it's not. This needs to be a right angle here. And I know that it's not because I can see the slopes are not opposite reciprocals. If the slope of AB is 2/3, the slope of BC needs to be negative 3/2, and it's not, it's negative 2/3. So there's one information. Another piece of information we can check is using the Pythagorean theorem. If this was a right triangle, then we'd have AB squared, which is 13, plus BC squared, which is 13, equals AC squared, which will be 16. And that's not true. We do not get A squared plus B squared equals C squared. The Pythagorean theorem doesn't work. Great. Now notice I didn't do anything with Desmos yet. This was all just Pythagorean theorem. One thing where Desmos can help you is actually visualizing the points and then making sure you get the correct equations of the lines. So we have 0, 0, we have 3, 2, and we have 0, 4. Okay, and you can label it, but if we want to find the equations of the lines, we know we need a point and a slope. It comes from the slope formula. We have y minus y1 equals an m times an x minus x1. How However, for the equation of AC, we see it's going this vertical line, it's passing through 0, 0, and 0, 4. We should know that equation is x equals 0. X equals 0 will be a vertical line where all the x points are the same. For the other two equations, yes, we need a point and a slope. And we could use the same point. We could use the point that both of these lines are going to pass through. Or we can use different points. I could use 3, 2 because both of these lines are going to pass 3, 2. Or I could use 0, 0 for the AB line. And I can use 0, 4 for the BC line. So it's up to you. So I'll show both. For BC, you can use 2 and 3, knowing that your slope is negative 2/3. Or you could use 0 and 4, knowing your slope is negative 2/3. So just showing you y minus 2 equals negative 2/3, x minus 3. There's that equation. But if I also did y minus 4 equals negative 2/3, x minus 0, I also get that equation. So it's fine. We are finding all of the possible xy points that are connected to either of these points using a slope of negative 2/3. Well, the points are connected to each other through that slope, so it doesn't matter which one we pick. Maybe I'll write or. If you copy this down, that just shows me like you're not really trying. You should have one or the other. For AB, same thing. You could use 2 and 3, or you can use 0 and 0. So you got y minus 2 equals positive 2/3. Y minus 0 equals positive 2/3. And there you go. Why don't we keep one of the lines in the other line? That way we create our nice triangle. And if I was able to find that angle, I could see it's not 90 degrees. You don't know that. You don't have the ability to do that in Desmos graphing calculator. So we just stop there. All right, we got the point 1, 2 and negative 1, 8. Connected by line segment AB. And we're going to ask some questions. Slope of AB and the equation of the line AB. Well, I can see that the y change is plus 6 and the x change is minus 2. So the slope, which is the change over y over the change over the x, is negative 3. This is where your calculator can help you big time. If you typed in 6 over negative 2, it will simplify it for you. If it was something that could be simplified, you could press this button and you could simplify it. But we have just the number negative 3 as our slope. And the equation of the line, this is where maybe seeing the points will help us. There are the points, and getting the equation of the line. Y minus one of the y coordinates equals the slope times x minus the corresponding x coordinate. So double checking that. Y minus 2 equals negative 3, x minus 1. And you could have done that with negative 1 and 8 if I did 8 and plus 1. Great. What is the distance between the 2 points? Well, we can see the vertical change, the horizontal change. We could see the Pythagorean theorem. A squared plus b squared would be 36 plus 4 equals our length squared. So 40 equals c squared. C equals root 40. Great. Root 40 is my answer, but now we want to simplify it. The square root of 40 is that. That's the same as the square root of 4 times the square root of 10, which is 2 root 10. What is the midpoint? Well, instead of going all the way from one point to the other, we can kind of pause in between. Instead of going all the way minus 2 to get to negative 1, if instead of going all the way plus 6 to get to 8, instead, let's go halfway. From 1 to negative 1 minus 2, let's subtract 1 and get to 0. From 2 to 6, instead of adding 6, let's add 3 to get to 5. You could also have found the average, which is the middle of the two numbers, your x's and your y's. So there's the midpoint. Easy to find, just the middle numbers. You can see right there, 0, 5. Ooh, what's the equation of the circle centered at A that contains the point B? So now we want a circle that is centered at A and contains the point B. Well, the circle is all of the XY points that are connected to my center that has the same radius. So we have the middle at A, which is 1, 2. We are going to all of the possible xy's. We can see we have an x minus 1. We have a y minus 2 change. So this is x minus 1. This is y minus 2. And we already know what the r is. The r, which is c, is 2 root 10, or it's root 40. We know what c squared is, or r squared is. It's 40. So we have a squared plus a b squared equals c's square. That's 40. Great thing to check is graphing your equation of your circle, x minus 1 squared plus y minus 2 squared equals 40. You should see your circle that is centered at your center and that is passing through that point, which we do. What is the equation of the line tangent? So now we go to the last lesson where we know that there is a line that will just touch our circle once. It's going to be connected at B. We already know the slope of AB. The slope of AB is -3. So that means the slope of our tangent, since we create a perpendicular, would be +1, 3. We know that it's passing through point B, which is -1, 8. So I should have the equation y minus 8 equals 1/3 x plus 1. And what's great is if you have everything here, you should be able to see your center. The line going through your center, going through the point. It creates this diameter. You should be able to find the other point on the diameter if you want to, just by continuing with your slope. You can find the equation of your circle. You can find your tangent line. Everything should look correct. And it does if you're using Desmos. All right. Now we got CD. C is at -2, 3. D is at 6, 1. 6, -1. Cool. Finding the slope of CD and the equation of the line of CD. So I'm going from -2, 3 to 6, -1. I can see my y's decrease by 1. My x's increase by 8. So my slope is y's over x's, which is -4 over 8. Here's a good little example of great things about Desmos. If you type in -4 over 8, you can see by clicking this button that slope is -0.5. And including one of our points with that slope, we will get the equation of the line. I'm using the 0.6, -1. And I should see the point -2, 3. Should see the 0.6, -1. I should see that y plus 1 equals -0.5. X minus 6 is the equation of the line that passes through those 2 points. What is the distance between these 2 points? Well, we found the vertical distance is 4. We found the horizontal distance is 8. I will use a squared plus b squared equals c squared. 64 plus 16 is 80. So that means c squared is 80. C is the square root of 80. I need to figure out what the square root of 80 is simplified. I'm going to take 80 and start dividing it by the biggest perfect squares I can think of that could possibly go in. I find 16 times 5. So square root of 80 is the square root of 16 times the square root of 5, which is 4 times the square root of 5. Cool. So that is the length, 4 root 5. Let's find the midpoint. Well, from -2, 3 to 6, -1. Instead of going down 4, let's stop halfway and go down 2, and I get to 1. Instead of going +8, let's stop halfway and just go halfway and add 4. And I get to this point 2, 1, which I can really see here if I drew an accurate line. Ooh, what's the perpendicular bisector? So we have this point 2, 1. We know the slope of this line is -1/2. So we want a line that goes through 2, 1 because it's going to split CD in half. But our slope needs to be an opposite reciprocal. So instead of -1/2, it'll be +2/1, giving me y minus 1 equals 2 times x minus 2. And we should be able to see that going through the midpoint 1, 2, or sorry, 2, 1, there it is, that y minus 1 equals +2 x minus 2 is that perpendicular bisector. Beautiful. The endpoints of the diameter of a circle are -2, 4, and 10, 4. Okay, new question. I'm kind of done with that question. So -2, 4 and 10, 4 create a diameter of a circle. So what does that mean if it creates a diameter circle? Well, it is going from one end of the circle to the other. And if I connect it with a line, that line is going to go straight through the middle of my circle. Cool? Well, we can see that they're in line with each other horizontally. So if I'm going from -2, 4 to 10, 4, I can see there's no y change. All right, well, since there's no y change, all I have to worry about is this x change, and this x change is 12. So that means this entire length from one point to the other is 12, which means halfway will get me to the midpoint and will also give me my radius. So the midpoint is going to be -2 plus 6, or 10 minus 6, which is going to be at 4, 4. There is that middle of my circle. And now I have a radius that is 6. So how do I find all of the possible points? Well, I'm looking for the xy points that will all be 6 away from the point 4, 4. Well, this is where we think about the x change and the y change, and we use the Pythagorean theorem versus like the slope. So we're not using a y2 minus a y1 over x2 minus x1 equals m. We're using a squared plus b squared equals c squared. So I should have the equation x minus 4 squared plus y minus 4 squared equals c's squared. And we should be able to see that graph. Okay? If we're using Desmos, there's no reason we get anything wrong. Okay. Now we're on to JK. -2, 1 to -3, connected by a line segment. Might as well start everything over in Desmos. -2, 1, and 2, 3. To -3. Let's find the midpoint. Well, from -2 to 2, I'm adding 4. From 1 to -3, I'm subtracting 4. So let's add 2. Let's subtract 2 to get to the point 0, -1, which we can see right here. And we can plot. Great. Find the equation of the circle M that contains the points J and K. So we want the circle that is going to be centered at M that contains the points J and K. I can't believe it didn't snap into a circle. Great. Well, I got to find the radius. Okay. Well, I'm going to say the radius is from the middle to one of these outer points. So I'm going to not go and worry about this +4 and this -4. Instead, I know that from the middle to one of my points, I'm going to be plussing 2 and minusing 2. So it ends up being like half of the change. Whatever the change of the diameter was, the radius's change is going to be half of those changes. So I got an a squared plus a b squared equals a c squared. I got c squared equals 8, which means c is root 8. Simplify root 8. We've done it before. You get 2 root 2. So this is the radius, or this, and this is the radius squared. Which means if I want all of the xy points that are connected to 0, 1 and has a radius 2, I know the x change squared plus the y change squared equals the radius squared. So my equation should be x minus 0 squared plus y plus 1 squared equals the radius squared, or 8, not root 8. You should double check and make sure. Bam! You have that circle that you're looking for. Was the equation of the tangent line that passes through the point K. Point K is at 2, -3. So I want the equation of this line. It's going to go through the point 2, -3. But what is going to be the slope? Well, we know the slope of this radius is -2 plus 2. So it's a slope of -1. The slope of this tangent, therefore, has to be +1, or +2 over +2. If you write your equation of your tangent line, you got y plus 3 equals 1, x minus 2. Let's see. Y plus 3 equals 1, x minus 2. Bam! Done. Okay, we got a circle centered at 2, 3. Circle has a radius 4. Well, I want all the xy's connected to 2, 3. That has a radius of 4. If anybody made a mistake on the last quiz, they made a mistake on this problem. A squared plus b squared equals c squared. Here's why you got it wrong, is you didn't check. If 2, 3 is on the circle and the radius is 4, what's an easy point you could find? Well, add 4 to the x or add 4 to the y. Don't add 4 to both, because that's not going to be a distance of 4. But just go up or down, right or left 4. This is an easy way to check. You can look at the point 2, 3. You can look at the point 6, 3. You can make sure your equation x minus 2 squared plus y minus 3 squared equals, let's say we made a mistake and we said 4. Well, we can see it's wrong. But if we do 4 squared, c squared, now it's correct. Cool. Well, what if the x-axis was tangent to the circle? If the x-axis is tangent to the circle, that means we are going to contain the point 0, 2, or 2, 0. Now let's see here. If the x-axis is tangent to the circle, you almost have to kind of figure out that your circle is going to look like this, where this point here at 2, 0 is going to be the bottom of the circle. Well, if the point 2, 0 is the bottom of the circle, we must have a radius of 1, 2, 3. 3 to 0. Just that. So we can kind of be able to visualize that we're still going to use x minus 2 squared, y minus 3 squared. We're still centering at 2, 3, but now the radius is 3. So if I do x minus 2 squared plus y minus 3 squared equals 9, I should see that x-axis being tangent to the circle. If the y-axis is tangent to the circle, well, then I'd have this point here, which is a point, like my circle would have to be smaller so that I figure out, oh, yeah, okay, which is going to be the radius. Well, we can see it's got to contain the 0.03. So we have this horizontal radius making a vertical tangent. And we can see that this distance here, this radius is going to be 2. So we're just going to make sure we have the radius squared, which is 4. All right, we have another center, 5, -1. Let's find our radius. So I know all of my xy points will have x minus 5 change and a y plus 1 change. So I have x minus 5 as my a squared plus y plus 1b squared equals, now I have to find the radius of the circle. The radius of the circle we can find using these 2 points. We go from 5 to 10, which is plus 5. We go from -1 to 11, which is plus 12. So I have 5 squared plus 12 squared equals c squared, or my radius squared. So we got 25 plus 144, which is 169. That's c squared. We have the square root of 169, which happens to be the number 13. That's very good. So c squared is 169. C is 13. But remember that in the equation of a circle, it's a squared plus b squared equals c squared. I should have 169. This is a great thing to check. We have x minus 5 squared plus y plus 1 squared equals c squared. We should have the point 5, -1. We should have the point 10, 11. Well, bam. Write 2 horizontal tangent equations and 2 vertical tangent equations to the circle. Well, this is the nice thing about having a radius that is 13. We should be able to get 4 easy points on the circle, and we should be able to see what the horizontal and the vertical tangents look like. So what are these 4 easy points that are going to be 13 away? Well, we can add 13 and subtract 13 from the x and the y's. Adding 13 to 15 is 18. So this point is 18, -1. Subtracting 13 from 15 is from 5. 13 from 5 is -12. Oh, geez, -8. Horrible. So I have -8, -1. Great, that's that point. Subtracting 13 will be -14 from my y. Subtracting, adding 13 from -1 will be 12. So I got this point. So I could plot all these points. You could also see those points. That is not the correct point. That's the point. All right, cool. So that's good. So I got 5, 12. I got 18, -1. I got 5, -14. I got -8, -1. Cool. And now I can see what is the tangent at all of these points. Well, let's start at this point, 18, -1. I can see the vertical tangent. What is going to be the vertical tangent? Is it x equals 18 or is it y equals -1? Well, I can see the x is always 18. X equals 18 will give us this line. I can see x equals, gives us vertical line. So x equals -8 will give this that. 18 and then -8. And then we know if your y's stay consistent, you will have horizontal lines. So at this point up here, 5, 12, y equals 12 gives me that horizontal line that will be tangent. So I got y equals 12, and I'll have y equals -14. And you should be able to graph it. You should be able to see everything. And it should look so nice that you're like, I'm crushing geometry. All right, last question. The center of a circle has an x coordinate of 2. Nice. Okay, so the center of the circle is somewhere on this imaginary line where x is 2. Y equals 2 and y equals 8 are 2 horizontal tangent lines. This is a great question. So let me erase everything. The center of the circle is at x equals 2, y equals 2, and y equals 8. So I can see that right in between y equals 2 and y equals 8, I'm going to have like the middle. So midpoints, very important. So 2 to 8 add 6. Well, let's add 3 and we will get to y equals 5. We'll get to the center of the circle, which is going to be at 2 comma 5. This would be my diagram. Great. Well, we can see if it's at 2, 5, that my radius is going to be 3. So x minus 2 squared plus y minus 5 squared equals my radius squared. Again, how do we do this? All of the points on my circle will be all of the xy's, where the y change squared plus the x change squared equals the radius squared, or 3 squared. You should be able to see the beautiful x minus 2 squared plus y minus 5 squared equals 9 equation where y equals 2, y equals 8 are tangents. That's it. This is good stuff. It kind of builds upon itself. It's a really nice unit. I really like teaching it. So hope you guys are locked in for the test coming up. Peace.